Let's talk about the topic ratio. Sometimes it's referred to as ratio and proportion. Ratio is really a way of comparing two quantities using two or more quantities using a number to represent the size of each. So you know the size is in comparison to each other. Proportion is really the portion that a particular quantity takes or is allocated to one of those quantities. Alright. Now, when you talk about the ratio of, let's use two quantities, you have various examples, alright? It may be a case where you talk about the student or the teacher-student ratio. Let me type that. Teacher-student ratio. In a school, you have a teacher-to-student ratio. Let me just put up my... Alright. So, an example would be in a school, say a private school. They boast that our teacher-to-student ratio will not exceed 1 to 15. Alright? So if you have a teacher-student ratio of 1 to 15, it can be written as 1:15. That's the usual way to write down ratio. It is really a fraction. You are really saying 1 divided by 15. What that means is you have one teacher in a class, you will have no more than 15 students in the class. If there's one more student, of course, they could hire another teacher, and instead of having one teacher teaching 15 and one teaching 1, they could say allocate them 7 for one teacher, 8 for one. But as students keep coming in, you should have no more than 15 students being taught by one teacher. If a parent finds out that they have broken this promise and are having more than 15 students, then they could complain, and others would probably see these advertisements of this private school as a lie or as a scam. So that's one example of ratios. Another example could be when you're dealing with house drawing. Right? I believe I didn't have my main topic up here. Okay, so our main topic ratio. Let me make it stay here. When you're dealing with house drawing, one common scale that use is 1 to 50. Let me put down house drawing first of all as another example. Or it could be building plans. When you talk about building plans, you're really talking about the scale when you're dealing with the ratio. For example, one common example of a scale used on building plans is 1 to 100. That is a ratio. It's a ratio of the size of the plan to the size of the house. Or let's not use size. because you might also think of size as the area or a volume of a room. The length between two objects on the plan compared to the house length. For example, it could be on the plan one between a door and a switch, and a certain light switch is 1 centimeter. On the actual house, it should be 1 times 100. Since it's 1 to 100, 100 centimeter, which is the same as 1 meter. All right. So when you're dealing with building plans, you're talking about ratio when you compare the drawing to the actual house. For a housing development with a few houses, it might be more than that. It could be, for example, 1 to 500 for a small housing development. It could be 1 to 3,000 for a larger housing development. All right. So these are two examples where you find ratio being applied. Another example, if you're interested in electrical installation or electrical engineering, we're talking about the voltage ratio of transformers. The transformers, those are some of those cylindrical things you see on the light poles, right? What they do is convert the voltage to your house, or the voltage from your power company. Usually they step it down to a lower voltage that is safer to use in your house. So a voltage ratio might be 1 to 100 as well. What that means, and remember, and let me backtrack a bit. When I said teacher to student ratio is 1 to 15, you could also be talking about student to teacher ratio as 15 to 1. All right. So these can be used in any direction you want. 1 to 100 means the voltage at your house, 240 volts, supplied by the transformer, to the voltage coming in from the power company. In this case, it would be 240,000. So it's 24,000 volts, which is referred to as the high voltage side of a transformer. And then to your house, you have 240 volts, and then they split this in half and half, 120 volts plus 120 volts between the three lines that you have. If you're interested in automotive engineering, there is the issue of ratio and proportion. When you talk about, for example, the gear ratio. All right. So car gear ratio. Now, of course, you have nowadays a movement towards using electric cars, which don't have these type of traditional gearboxes that we have, right? But you still have most vehicles using either manual gearbox, usually large trucks and buses. Most cars are automatic, but they still use gear ratios. All right. So you have various gear ratios. I remember that a fourth gear has a 1-to-1 ratio. We're talking about two gears that mesh together, and you have the gear teeth. All right. So when it's a 1-to-1 ratio, it means the gears that mesh together are the same size and they have the same number of teeth. That's like fourth gear. A fifth or sixth gear might be less than a 1-to-1 ratio. See, this part is coming in from the engine, and this part is going out to the wheel. Now, when you have fifth gear, the gear coming in from the engine is a little larger, and the gear coming out to the wheel is a little smaller. So it might be 0.75 to 1. That means for every 0.75, every 3/4 turns of the gear coming, the shaft coming into the gearbox from the engine, you have 1 complete turn of the shaft going out towards the wheel. So in this case, you have an overdrive, right? But the first gear, in first gear, the gear coming in from the engine is small, while the gear going out to the wheel is large. So what you have, it could be, for example, a 3.5 to 1. That's a ratio, right? For every 3.5 turn of the shaft going into the gearbox, you have only one turn going out to the wheel. The advantage of the first gear is that even though it's slow, it's strong. The fifth gear is weak, but it's fast. So you're dealing with gear ratios when you're talking about the gearbox of a motor car. That's another example when you have to deal with ratio. Let's look at 1 or 2 more examples. You might have a case where you're mixing cement and sand to make mortar. All right, one common mixture ratio, right? Cement to sand. So one common ratio would be like 1 to 2, 1 to 2 ratio. Fairly strong. That will be fairly strong mortar. What that means, for every 1 bucket of cement that you are going to mix, you use 2 buckets of sand. All right, that's the cement to sand ratio. In that case, you could, as I said before, you could also reverse this thing, so that instead of cement to sand, what you have is a sand to cement ratio. So you have a sand to cement ratio in that case. Now, in switching it around, instead of saying 1 to 2, what you would say is 2 to 1 ratio. What that means, every 2 buckets of sand that you throw on the ground to mix, you use 1 bucket of cement. All right. So these are just a few examples of ratios in life. You have to deal with ratios in many other cases. It could be a recipe that you're mixing to bake a cake or to cook, and you have ratio of, say, flour to a certain seasoning, right? Whatever it is. It could be the ratio of boys to girls in a school or in a certain class, right? So we have to deal with ratios in a lot of different cases. So a ratio basically is a comparison of 2 quantities. All right. So back to this 1 to 2. Cement to sand. What this means is that if you have 3 buckets of cement available, and you have a lot of sand on site, only 3 buckets of cement, you can't get any more today, you should be able to figure out how many buckets of sand you're going to be using with these 3 buckets. With these 3 buckets of cement. So since it is a 1-to-2 ratio, you can call all of this 1. That's the cement. When it comes to the sand, you have 3 buckets, and that is 1. That matches the amount of cement, but you should have 2 times when you're talking about the amount of sand. So you do it again, and you have 2. So 3 buckets of cement, you must mix 6 buckets of sand. If you are going to mix 5 buckets of cement, you will need twice that, 10 buckets of sand. Alright? Later on we'll look at examples of these things and do some calculations. For example, it could be where you have 30 buckets of cement and sand mixed together. How many of them are, how many buckets of sand were put together for this mixture? Right, those types of questions we're going to be doing at a later date. But we'll leave that for now, and I will see you later.